Okay, so a quadratic function, right, or a quadratic equation has this some form, right? This is the standard form of a quadratic function, ax squared plus bx plus c. So notice you have the power of 2, right? So to re-jog your memory, remember a quadratic is another way of saying a parabola, right? A parabola, you can have two types of parabola, right? So you can have a happy parabola or a sad parabola, right? So how do we know if it's happy or whether it's sad? Well, we look at, so this is happy, so positive and then negative, right? So we look at the leading term, right? A. So if A here is positive, then we have a happy parabola. If A here is negative, then we have a sad parabola. Okay? So that's how I always remembered it. Now, when we're solving these quadratic equations, so notice that we have a power of 2, right? So remember that each equation tells you literally how many possible solutions you'll have. So in this case, you can have up to two possible solutions, whether we're talking about the real world or some kind of imaginary or complex world. Okay? But in this case, we're looking at two possible solutions. So when we're solving these quadratic equations, what's happening? What's the behind the scenes? That's what I'm trying to get at here. So in this case, you'll have three different scenarios, just like you would with the linear equations we talked about last time. So one possible scenario would be like this, right? Another possible scenario would look something like this. And then the other one would be something like this. Okay. So again, when you're solving these quadratic equations, you're going to have three types. Okay. So in this case, for this one, we're looking at, so notice that this is, this is the x-axis, right? So in this case, it's crossing the x-axis twice. Okay. So for the first example here, the solutions for this one is going to be 2, okay, because it crosses the x-axis twice. Now, how about if we look at the second one, second drawing here, this one looks like it's only crossing one time, but technically it's called one repeated solution. So that means you can have the same factor twice. So when you solve it, you get the same answer. Okay, and we'll see that as well. And then this one here is, notice that it never crosses the x-axis at all. So in this case, we have 0 solutions here, okay? Because it doesn't cross the x-axis. So again, when we're solving these quadratic equations, we're trying to figure out how many times do they cross, if they cross at all, through the x-axis, okay? Sometimes we call those roots, x-intercepts. Sometimes what we have to do is we have to factor them in order to find where those exactly, in fact, that's exactly what we're going to be doing, but to find those where they cross the x-axis. Okay, so let's do some um, starting examples to kind of re-jog your memory here. So in this section, let me, and there we go. Okay, so in this section, we're going to learn different methods of solving these quadratic equations. Okay, the first method is by solve by factoring. Then we're going to go to solve by the square root method, then solve by completing the square, and then solve by the quadratic formula. All right, so you need to learn all these methods for your exam. Okay, so it's going to ask you solve this by factoring, solve this by completing the square, so on and so forth. So again, make sure this is a checklist of what you need to know uh, for your exam. Okay, so in this case, so let's look at some examples. Okay, so this one's just um, a simple one. So we want to solve this by factoring, and let's say we have x squared plus 6x plus 8 equals 0. Okay, so x squared plus 6x plus 8 equals 0, and we want to factor these. Okay, so Remember, what we need to do is we need to find factors of 8. All right, so you can do this if you want to, but you're not required to. So I kind of do this little cross method here where I have the center plus, and then here I have last multiply. Okay, so when I'm talking about the center number, I'm talking about this one here. Okay, it's number 6. And then the last number here, I'm going to, so center number and then last number. Okay, the last number I'm talking about 8. Okay, so center, last. Okay, so I'm going to put those numbers there. So 6 and 8. And what I want to do is I want to find factors when I add them. Okay, it's going to give me 6. And then when I multiply those, it's going to give me 8. All right, so that's what it's saying. So this one's to add and this one's to multiply. Okay, so I need to make a list, right? So I need to list the factors of 8. So you have 1, 8, 2, and 4, right? This one's nice because everything's positive, so all we have to worry about are positive. Okay, so if we pick 1 and 8, that one's not going to work, right? Because 1 plus 8 is not going to give you 6. 1 times 8 does give you 8, but not 1 plus 8. Okay, so that means that we don't use that one. All right, so how about the second one? We got 2 and 4. Well, let's see. If I add them, right, 2 plus 4 is going to give me 6. Okay, and then when I multiply them, 2 times 4 is going to give me 8. So they both check out. Okay, so that means then this is the two factors that I want. So I write 2 and 4 here. Okay, so then I'm going to now equal this to the two factors. So x plus 2 times x plus 4, okay, and equal that to 0. So that means that I need to set them both to 0. So x plus 2 equals 0, and then x plus 4 equals 0. And I solve for x. So I subtract 2 on both sides here, and that gives me -2. I subtract 4 on both sides here, and that gives me -4. All right. So these are going to be my solutions to this quadratic equation. Okay. All right. So let's look at another one here. And why don't you try this one? So let's say we have say x squared plus 2x minus 8 equals 0. Okay, go ahead and try that one. All right, thank you for those who submitted their answers. So let's look at this. So again, I'm gonna, make my x here. And then so the top of this x, I'm going to put my center number, which is 2. And then my bottom of this x, I'm going to put -8. Okay, so again, I want factors. When I add them up, will give me 2, and then when I multiply them, will give me -8. So in this case, we need to not only look at the positive, but also the negative numbers as well, correct? Because now we have plus and minus. So we need to find, so we have the factors of 8, which we already know, which are 1, 8, 2, and 4, but we also need to list the negative as well. Okay, all right. So So in this case, it looks like, what do we get here? 4 and -2, right? So if I add them, 4 plus -2 will give me a +2. And then when I multiply them, I get 4 times -2, which gives me -8. And that's what I want, right? So we want a +2 for the center number, and we want a -8 for the last number. So that means that these are going to be my two factors. Okay, so I'm going to have x right over here. So we're going to have x plus 2 times that by, sorry, that again. X plus 4 times that by x minus 2, okay, equals 0. Now, another way to show whether you got the correct factors are, you just multiply the center numbers here, 4 times x, and then you can also multiply the first number and the last number here, or the first term and the last term, and that gives us x times negative 2 will be negative 2x. So that gives us 2x here, okay? So when I multiply those. So that matches with the center term here. All right, so anyway, that's another quick way of doing it, just to make sure, okay, did I get those correct? Okay, 4x minus 2x, okay, that gives me 2x, so that's correct, okay? All right, so again, that's another way to kind of double check whether you got the factors correct or not. All right, so anyway, so we're going to set these equal to 0. All right, so that gives us negative 4 and positive 2. As I mentioned, it would be awesome if we have all of our trinomials are this way. It would be really easy to factor them all, right? But unfortunately, they are not, right? So what happens when that leading term is not 1? So these ones that we just demonstrated, the leading term is 1. So what happens when the leading term is bigger than 1? Okay, so let's look at an example. Another example. So again, it doesn't really matter what letter you use. So in this case, where we're using X, the next example, we're going to use P, right? So let's say we had 3p squared minus 2p minus 5 equals 0, okay? How do we factor that? So I'm actually going to show you a method that I learned many, many years ago. All right. So the method I'm showing you is called the slide method. Sometimes it's called the illegal move. All right. So again, the first step is you take that 3, okay, and you multiply it to the back, right? So you take that 3 and multiply it to the back. And that gives us p squared minus 2p minus 15 equals 0, okay? And they call that slide, all right? Or I just say multiply the first term to the last term, okay? Then the next part is you want to factor, right? So um, we use the X method here, all right? So we want, in the video, he does it the other way, and that's okay. I put my center number on top and then my last number on the bottom. But in this case, we've got to make sure that we're using this trinomial, not the one on top, okay? Because that's what we're trying to factor. So we have negative 2 and negative 15, okay? So in this case, the factors are going to be negative 5 and positive 3. So negative 5 plus 3 is going to give us negative 2, and negative 5 times 3 is going to give us negative 15, okay? And those are the terms or the numbers that we want. All right, so then we factor this, so that becomes p minus 5 times that by p plus 3 equals 0, okay? All right, now what students do sometimes though, or actually a lot of times, is they say, oh, I found my factors, and they solve it, and they say, oh, I'm done. No, so remember, whatever you had multiplied at the beginning, you have to undo it. So that means that since I multiplied by 3, now I have to divide by 3. So again, students fall into the trap and say, oh, this is going to be p equals 5 and p equals negative 3, and I'm done. Okay, so I put a star on that because again, that's a common mistake students make. That's not what you do. Okay. So what we need to do again is, since we multiply by 3, we have to divide by 3. So we only divide the terms or the that have no variables. Okay. And then we reduce. Okay. So 5/3 doesn't reduce. So whatever we don't reduce, we just bring it to the front. So that becomes 3p minus 5. And same thing for this one. We got 3 divided by 3. When we reduce that, that gives us 1. So that would be p plus 1 equals 0. Okay, and that's how simple it is to factor. If you don't believe me, you can factor it out. I'm sorry, you can multiply this out, and again, you'll get the same thing as the original. line here. Okay. And then since we are solving means we need to find what those variables are representing. So we set them both to equal 0. Okay. So in this case, we get p equals 5/3, and this one is equal to -1. Okay. All right. So let's try another one here together, and then I'll let you guys try one on your own. So I'll do it on this side here so you can use it as a reference. Okay, so let's look at this one. So let's say we have 9x squared minus 3x minus 2 equals 0. Okay, so again, the first step, what we need to do is we need to take that 9 and multiply it to the back. Okay, so that gives us x squared minus 3x minus 18 equals 0. Okay, then we need to find the factors. Again, you don't have to keep drawing the x there if you don't want to. If you want to do something else, that's fine. You want to go straight to, if you already know what they are, perfect. Just go straight to the next step here. Right? So in this case, when I factor this, we get x minus 6, and then we get x plus 3. Again, you can do a really quick check. This one is minus 6x. Okay, and then the outer terms are x and 3, so that's a plus 3x. So that gives me a negative 3x, and that matches with the center number here, or center term. Okay, so again, that's a nice and quick and easy way to verify whether you got your factors, or especially, students mess up on whether it's a positive or negative. That's a common error as well. Okay, so once we verified that, so now since we had multiplied by 9, now we're going to divide by 9. Okay, and again, you only divide the numbers, not the ones with the variables. So once we divide, then we're going to reduce. Okay, so this one, I should have wrote down divide and then reduce. Okay, so this reduces to 2/3. Right? The 6, 9 reduces to 2/3, and this one reduces to 1/3. Okay, and that's again equal to 0. Then we set them to 0, and then we solve. So we get x. Oh, sorry. Let me backtrack here. All right. Getting ahead of myself. All right, okay, so now we can't reduce them any further, so what we need to do is bring them to the front. So that gives me 3x minus 2. And then this one will be 3x plus 1 equals 0. Okay, and then now we can set them both equal to 0 and solve. Okay, so we add 2 on both sides and divide by 3. So x here gives us 2/3. And this one we're going to subtract 1 on both sides and divide by 3. So x gives us negative 1/3. Okay, and then those will be our answers. Okay. Again, another way to verify this is just to multiply. So if you multiply these two factors here, right? If you multiply these two factors here, you'll get the same thing as the original line you had, okay? So that's another way to verify whether you got this correct or not. Just multiply them out. And if you get the same thing as the original statement, perfect. Okay? If you didn't, it means, there is something wrong in one of the calculations here. Okay. Okay, so again, the first thing you need to do is we need to take that 3 and move it to the back, right? So we need to multiply it. So take the 3, multiply it to the back. So we get x squared minus 10x plus 24 equals 0. Then we factor. Okay, so now if you have a minus positive combination, again, if the minus here is in the middle and then we have a positive in the back, both of your factors will always be negative. Again, if you have a minus positive combination, both of your factors will always be negative. So that means I would get x minus 6 and then x minus 4. Okay, so that's what I mean by the factors being negative. Okay. Now, since we multiply by 3, we need to divide by 3. So we divide the 6 by 3 and divide the 4 by 3. Now, all of them just the numbers without the x's. Then we reduce. So that becomes x minus 2. And this one doesn't reduce anymore. So then I can just bring that to the front. So that gives me 3x minus 4 equals 0. Okay. And then I solve. So I get x minus 2 equals 0, and then 3x minus 4 equals 0. Okay, so x here gives me 4/3, and x here gives me 2. Okay, so I just want to address something real quick before I move on here. So again, this is called the slide method. And the slide method only works, number one, is if the leading term is positive. Okay, so number one, so these are to be cautioned, the leading term must be positive. Okay. All right. So if it was a minus 3x squared, we couldn't do it. All right. So what we need to do is we would just divide everything by the negative. So again, if I had a minus 3x squared, plus 10x minus 8 equals 0, then we would just divide everything by a negative. Okay. And then that flips everything. So that becomes 3x squared, a minus 10x, and then the plus 8 equals 0. Okay. All right, so again, be careful of that. The other part is if there is a common factor. Okay, so let's say I doubled everything here, and this was like a 6x squared minus 20x plus 16 equals 0. Okay, and they wanted me to factor this. But notice that you have a factor of 2. Okay, so I would factor out a 2, and that gives me 3x squared minus 10x plus 8 equals 0. Okay, so if there is a common factor, factor it out. It gives you less work. I believe you can still work it out this way, but it's going to be a little bit more work. All right. So again, if there's a common factor between them, factor that out. Okay. Now you can work something with this rather than multiplying that 6 and that 16 and getting a bigger number. Okay. So just be cautious of these two things, two parameters, when you are using the slide method. Okay. All right. So the first step here for the on the first example, right? We need to distribute the x. Okay. So we got to do that. So we can't say x is equal to 12 and x plus 4 is equal to 12. Okay. Because if we try to solve that, minus 4, that gives us 8. When if you plug it back in there, it's not going to equal 12. Okay. So again, don't do that. Okay. In order for this to work, it has to equal to 0, right? But again, that's another common mistake students make. Like, oh, it's equal to 12. I'll just, set them both equal to 12. Okay. That is not correct. All right. So what we need to do here is we need to distribute that term. So we're going to distribute that here. So x times x is x squared. This will give us 4x equals 12. And we have to have it in the form of ax squared plus bx plus c equals 0. So that means we have to take that 12 and move that to the left. So it'll be x squared plus 4x minus 12 equals 0. Okay, now we have it in standard form. Now we can factor it. Okay, so in this case, we'll have x plus 6 times that by x minus 2 equals 0. So in this case, x will give us minus 6 and positive 2. Okay. All right, for this one, the second one, right? We've done this before, right? That's basically one of the first things we did. This is dealing with the LCD, correct? So we have a denominator, so we need to get rid of that denominator to solve this. So in this case, um, our LCD is going to be X, right? So our LCD is X. So that means I'm going to multiply each one of these terms by X. So we'll get X squared plus this X will cancel. We'll have 12 left over, and then we have 7X. Okay. And again, we have to put this in standard form where everything's on the left side, and then there's only 0 on the right. So we're going to move the 7X to the left, and that gives us X squared minus 7X plus 12 equals 0. I like to have them in order so I can factor them easily. Okay. So again, we have a minus positive combination. So that means then both factors have to be negative. So we'll have X minus 4 and then X minus 3 equals 0. And again, we set them both equal to 0 and solve. So X gives us 4 and then X gives us 3. Okay. All right. On this next one here, what do we have to do first? Let me pause. Okay. All right. So, oops. All right, so again, we're going to move that 40x to the left side. So that's going to give us 25x squared minus 40x plus 16 equals 0. Okay? Now trying to find a common factor because these are kind of big terms, but we have a 5 that's an odd number, then 40 and 16 are even, so there is no common factor between them. Okay? So what we need to do now is we need to take that 25 and multiply it to the back. So we get x squared minus 40x plus 25 times 16 is going to give us 400. Okay, now we need to find factors of 400, and there's several of them, correct? But we find out here got negative positive, so that means both factors have to be negative, and found that 20 times 20 is 400. So our factors here are going to be x minus 20 and then x minus 20. Okay. All right. So again, because I have that negative positive combinations, that means both factors have to be negative. Now we have to be careful because, as I mentioned before, some students say, "Oh, the answer is going to be 20." That's not true. Okay. Since we multiply by 25, we have to divide by 25 and then reduce. So this is going to be x minus 4/5 and then x minus 4/5 equals 0. And then we're going to take that 5 and move it to the front. So that gives us 5x minus 4 times 5x minus 4 equals 0. Now, since they're both the same factors, okay, then we just need to do one of them. We don't have to do both of them. So x gives us 4/5. Okay. And this is what they mean by a repeated solution because you get the same factor twice. Okay, so this is what they means by one. Means by one repeated solution. Okay, so if you see that in the book. Okay, so we learned about solve by factoring. All right, so next one is we're going to be learning about solve by the square root method. As I mentioned, as we do these other methods, the previous methods are going to be embedded into them. All right, so it's important that we understand the building blocks to this next method. Okay. All right. So the next one is we're going to learn by solve by the square root method. Let's write that down. Solve by square root method. Okay. So we've, done something like this before. So for example, if we have x squared equals 36, right? What we need to do is we need to take the square root of both sides. So when we do that, what do we get? We get x is equal to what? Just 6? What else? Exactly, right? We get positive and negative 6. Very good, right? So we have plus and minus 6. So again, we have to be careful because we have a power of 2. So that means we should have two possible solutions, right? Because 6 times 6 is 36, and minus 6 times negative 6 is also 36. Okay, so we should have two possible solutions here. Okay, all right, so again, we're solving this by the square root method. So let's look at the next example. So let's say we have x plus 2 um, square equals 1. Okay, so again, we have a square here. All right. So, and we need to solve this by the square root method. So that means in order to get rid of the square, we have to take the square root. Okay. So we take the square root on both sides. So the square, I'm sorry, the radical and the square are going to cancel. Okay. So that gives us x plus 2. And what do we get for the right side? What's that going to be? Again, is it just 1? Plus and minus 1, right? So again, be careful with that. So we're going to have two separate equations. We have plus and minus 1. All right, so we're going to have x plus 2. And again, this is a common mistake students make. We're going to have x plus 2 minus 1, and then x plus 2 equals positive 1. Okay, so we'll have two separate equations. So we just subtract here on the left side. So we have x is equal to negative 3. All right, and on the right side, we also subtract and we get x is equal to negative 1. So that cancels and that cancels. Okay, so those are our solutions there. Okay, so why don't you guys try one and see what you get. So let's say we have 3z minus 2 square equals 4. So we have 3z minus 2 square equals 4. Okay, so let's go through this. So again, the first thing we need to do is we need to take the square root on both sides, right? Because we have a power of 2 here. So take the square root on both sides. So the square and the radical go away. We get 3z minus 2. And the square root of 4, again, is going to be two possible solutions, plus and minus 2. Okay? Then we're going to have two equations. 3z minus 2 equals negative 2. And then 3z minus 2 equals positive 2. Okay? So we're going to add 2 to both sides. Okay, so we get 3z is equal to 0. Divide both sides by 3. So z equals 0. Okay, 0 divided by any number, okay, besides 0 is going to give us 0. Then we do the same thing here. We're going to add 2 to both sides. So that gives us 3z equals 4. Then divide both sides by 3. So z gives us 4/3. Okay. All right. Any questions on this? Okay. All right. So let's go back to our list here. All right. And okay, so we just completed solving by the square root method. Okay. So the next one is probably the hardest one of all, and that's going to be completing the square. Okay. So most students don't do so hard on this on the exam. Okay. So let's look at that. So this one is dealing with, we're going to solve by completing the square. Okay. All right. So, you know, but let's just look at the problem. So we say x squared minus 6x minus 13 equals 0. Okay. I have x squared minus 6x minus 13 equals 0. So are there any factors of 13 that will give me a minus 6 and a minus 13? Or am I able just to factor this regularly? Okay. Right. No, right? Because 13 is a what? A prime number, correct? So it can only have 1 and 13 as your factors, and there's no other factors. There's no way I can, get a 6 out of it. All right. So that means then, we get stuck. So we need to find alternative methods of factoring. And the one method we actually use a lot in math is called completing the square, especially when you get to the upper levels. Okay, we use this a lot because again, not everything is nice and dandy. You can able to factor it. So you have to find other methods of doing it. Okay. So what do we do? Well, the first thing is so remember I said we have ax squared plus bx plus c equals 0. The first thing we need to do is we need to take that c and move it to the right. Okay? We're going to take that c and move it to the right. So that means we got a negative 13 here. Okay? We got a negative 13 here. So we got to move that to the right. So that's going to give us x squared minus 6x equals 13. Okay? So that's the first thing we need to do. All right? The next step is we need to find, well, we need to factor it. But in order to do that, we need a formula, okay, to find another term so are able to factor. So the formula we're going to be using is b over 2 square, okay? All right. So again, we have this is my a, this is my b, and that's my c, okay? So in this case, my b in this case is going to be minus 6, okay? All right. So before I do that, I'm going to put here, I'm going to say I'm going to add a box and then I'm going to add a box on this side. So it's like I'm balancing. When I'm adding on one side of the equation, I must do it on the other side. Okay. So what's going to go into that box? And that's what we're looking for. Okay. So the box, let me pause this for a second. Okay, that box is coming from this formula. So this box is equal to this. Okay. That's what we're going to put in. So the box here, so b again, as I mentioned, is minus 6. So we're going to divide that by 2. We're going to keep that negative, right? So it's minus 6 divided by 2. And then we're going to square it. So minus 6 divided by 2 is negative 3 square. And then negative 3 square is going to give us 9. Okay? So that means then I'm going to add 9 to both sides. So that's what's going to be in my box. Okay? I'm going to put a 9 here, and I'm going to put a 9 here. Okay? All right? So then I'm now ready to factor. Okay? So I'm going to factor the left side, and I'm going to simplify the right side. Okay? All right. So in this case, we're going to have x minus 3 times x minus 3, because again, we have a minus positive, so that means both factors have to be the same. And on the right side here, we get 13 plus 9, which is 22. All right. Now, we have the same factor, so this is our goal. Okay. This is our goal, to get the same factors. Okay. That's our goal. If we don't get to this goal, we have not achieved our goal. Okay. We have to get the same factors. So once we do that, then um, we're going to rewrite this. So x minus 3 times x minus 3, I can rewrite that as x minus 3 square, which equals 22. So notice what this is. This is what? The square root method, right? This is just the square root method here. Okay. So that's just a square root method. So we're going to take the square root on both sides. Okay. And then we have x minus 3. And the square root of 22, we can't simplify that any further. Okay. Because 2 times 11, there's nothing else. Okay. So we're going to leave it as square root of 22. But again, we took the square root, so that means we should have two possible solutions. So we're going to have a positive and a minus square root of 22. Okay. All right. Now then I'm going to have my two equations, but in this case, I don't have to do that because all I have to do is just add 3 on both sides. And I get x is equal to 3 plus minus the square root of 22. All right, so it still produces the two equations, and then I have to write it in two separate ways. All right, so again, our very first step is to move. So again, we want to solve this by completing the square. That's what it's asking us to do. You could try a different method, great, but again, you need to solve it by completing the square. All right, so we're going to take that 4 and we're going to move it to the right, okay? So that's the very first step. So hopefully you did that. So we have x squared plus 5x equals now -4. Then we're going to add a box. We're going to add a box here, and we're going to add a box here, okay? And in that box is going to be the equation, I'm sorry, the formula b over 2 squared, okay? All right, so b in this case is going to be 5, right? This is our b. B is 5. So it's going to be 5 over square, 5 over 2 square, okay? Which gives us 25 over 4, right? Because it's 5 over 2 times 5 over 2, right? It's just written twice. So 5 times 5 is 25, and 2 times 2 is 4. So 25 over 4. So that's what we're going to put in, okay? I'm going to put that in here. So 25 over 4, and then 25 over 4. All right. Now we're going to factor. Well, you might ask, well, how do I know which are my factors? These are fractions. Well, I'll give you a hint. So if we look at the previous problem, right, when we factor this, we got x minus 3, x minus 3. Okay. If you look here, before you get to your answer, so we got 9 here as our answer. Before we get to the answer, we had reduced this to -3. Okay. So that will always be your factor. Right before you get to the answer, before you square it, that will be your factors. So in this case, okay, in this case, we have 5 over 2, right? This is our answer. If we go to the previous step and we have 5 over 2. So those are going to be our factors, okay? The 5 over 2. All right. So in this case, we'll have x plus 5 over 2 square, sorry, times x plus 5 over 2. Okay. And again, of course, I know how much y'all love fractions. So -4 plus 25 over 4. So we need a common denominator. So that's going to be -4 times 4 over 4. Okay. Plus 25 over 4. So that gives us -16 over 4 plus 25 over 4. So that's going to give us 9 over 4. Okay. So this will be 9 over 4. All right. So we're getting close. So we get the same factors, okay? That's what we want. Check. So then we rewrite this as x plus 5 over 2 square equals 9/4. Okay? Then we apply the square root method once we get to this point. Okay? So we're going to take the square root on both sides. Okay, so the radical and the square cancel, giving us x plus 5 over 2. And the square root of 9 over 4, well, the square root of 9, that's just going to give us 3, right? And the square root of 4 is just going to give us 2. Okay, so remember, I can break that down to square root of 9 over square root of 4. So that gives us 3 over 2. But we have to be careful because this is, this is a power of 2, so that means we have to have 2 possible solutions. So we also have to consider the -3 over 2. Okay. All right, so then we just set them both equal to 0. I'm sorry, to the plus the the 3 over 2. So x plus 5 over 2 minus 3 over 2, and then x plus 5 over 2 plus, I'm sorry, equal to positive 3 over 2. Okay. So we're going to subtract 5 over 2 here, subtract 5 over 2. So that cancels, leaving us with -8 over 2, which is -4. Then we're going to do the same thing here. So that's going to give us x is equal, this cancels. leaving us with minus 2 over 2, which is negative 1. Okay, so those are our answers. Okay, so we have this next example of 2x squared minus 8x minus 5 equals 0. Notice the one that we just did, right? We had 1x squared plus 5x plus 4, and the previous one was 1x squared minus 6x minus 13 equals 0. In order to complete the square, the leading term has to be 1. In order to complete the square, the leading term has to be 1. That's 1. That's 1. If the leading term is not 1, then we can't do it. Okay? So that means here we have a leading term of 2. So again, in order for us to complete the square, we must have a 1 in the front. So how do we make that 2 become a 1? What do we do?
Divided by 2.
Perfect. We divide everything by 2. That's exactly what you need to do. Okay? So that becomes x squared minus 4x minus 5 over 2 equals 0. Okay? And then now you can go through that same process. Okay? Okay, um, so again, the first thing we need to do here after we divide by 2 is we move the negative 5 over 2 to the right, correct? So we move that to the right, and so that gives us x squared minus 4x equals 5 over 2. Then we're going to add our boxes, okay? And then remember in the box, we use b over 2 square, okay? So now we have to be careful because we did change this. This was our original, but since we divided by 2, we actually need to use the negative 4, not the negative 8, okay? So need to be careful with that. So in this case, we have negative 4 divided by 2 square. So that gives us negative 2 square, which gives us a positive 4. So that means then we need to add 4 in both sides. Okay. All right. Then we just factor. So we're going to factor this. So we got minus positive, so that means both of our factors are going to be negative. So x minus 2 times x minus 2. And then we're going to simplify this. So 5 over 2 plus 4. We can multiply that by 2 over 2 to have the same common denominator. So we have 5 over 2 plus 8 over 2, which gives us 13 over 2. Okay, so this would be 13 over 2. All right, now we need to rewrite this. So we'll have x minus 2 square equals 13 over 2. And then we're going to take the square root on both sides. So that gives us x minus 2. And then we have to be careful because, again, this is a square root and we have a power of 2. So we have to have plus or minus the square root of 13 over 2. Okay. And then we just add 2 to both sides. So that we get x is equal to 2 plus minus the square root of 13 over 2. All right. Now, for some reason, let's say my lab math doesn't take that. Well, we can simplify this a little bit further by breaking this down to radical 13 and radical 2. And remember, in order to get rid of the radical in the denominator, what we can do is we can multiply Or we can rationalize the denominator, which means we can multiply top and bottom by the same radical 2. Okay? So that becomes radical 2 times radical 13 times radical 2 over radical 2 times radical 2, which is basically radical 4. Okay? Which gives us, again, I can combine the 13 and 2, which is radical 26 over 2. Okay? Because radical 4 is 2. So again, I can have this, or I can have this as our answer. Okay? For me, it doesn't matter, but just in case my lab math, sorry, just in case the lab does not take it. All right, so let's go back to the methods we need to learn. We did solve by factoring, solve by square root method, solve by completing the square. So we just completed that. So now we just need to work on the last one here, which is solve by the quadratic formula. Okay, which I believe most of you are familiar with. Okay, so in the last method we need to know is the quadratic formula. Okay, so um, So again, we're using the standard form of ax squared plus bx plus c equals 0. And then the quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Okay. Now, and then here we have the discriminant. The discriminant is talking about inside the radical. So when I solve these, I like to work inside the radical first, and that will tell me whether I have a solution or not. If I don't, then I don't need to keep going through the whole quadratic formula, right? So in this case, if the inside that radical, okay, the discriminant, if it's greater than 0, then you have two real solutions. If it's equal to 0, that means you have one repeated solution. And if it's less than 0, there's no real solutions. Okay, because again, you can't take the square root of a negative number in the real world. All right, so let's go through a couple examples here. So let's say we have um, let's say we have x squared plus 4x plus 2 equals 0. Okay, so we have x squared plus 4x plus 2 equals 0. So the very first thing we need to do is we need to identify what our a, b, and c are, right? So 1 in front of the x squared, right? In front of the x squared, there's a 1, so that's going to be our a. Then this 4 will be our b, and then 2 here will be our c. Okay, and then we just plug it in. All right, so we're going to have um, negative 4 plus minus the square root of 4 square minus um, 1, sorry, 4 square minus 4 times 1 times 2, okay, divided by 2 times 1. Okay, so again, like I mentioned, I like to do inside the radical first to see if I get anything. So 4 square, that's going to give us 16, right? And then we got 4 times 1 times 2. Well, that's going to give us 8. So let me do it here, actually. So we're going to get 16 minus 8, which gives us 8, right? So, so that does work. So that's greater than 0. So we're going to have two real solutions. All right. So we're going to have here negative 4 plus minus the square root of 8 divided by 2, because 2 times 1 will be 2. Okay. And then I can break this down, this radical 8, to 4 and 2. So this can be broken down to radical 4 times radical 2, okay, which is equal to 2 radical 2, okay? So then I'll have negative 4 plus minus 2 radical 2 divided by 2, okay? So notice that each one of these has a factor of 2. So that means I can factor out a 2 And that will leave me with -2 plus or minus square root of 2 divided by, um, sorry, divided by 2. Okay? So now I can cancel the 2's here, one on top, one on the bottom, and then we're just left with -2 plus or minus the square root of 2. Okay? And then that would be our answer there. Okay, so we have 4x squared plus x plus 1. So let's label those. Okay. All right. So, all right. So this is our A, here's our B, and here's our C. So we get -1 plus minus the square root of B squared, which is 1 square, minus 4 times A, 4 times 1. Okay. All over 2 times 4. All right, so we get 1 here, right? So that'll be 1 minus 4 times 4 is 16 times 1 is 16. So that's 1 minus 16, which gives us -15. So we will get a square root of a -15, all right, which does not work. Okay, so that means then we stop and we say there's no solution here. Okay. All right, for the second one, again, this is our A, here's our B, here's our C. So we have negative. Now we have to be careful because it's a negative already. Then we have another negative. Okay. Plus or minus B squared. So that's a -20 square minus 4 times A, which is 25, times C, which is 4. Okay. All over 2 times 25. Okay. All right, so -20 squared. So I'm looking at the inside here. -20 squared is going to give us 400, correct? And then 4 times 25, that's like saying 4 quarters, that's 100 or a dollar. And then 100 times 4 is also going to give us 400. So that'll be 400 here. So 400 minus 400, well, that's going to give us 0. Okay, so here we're going to have, this is a minus 20, so that'll be a +20 plus or minus the square root of 0 divided by 50. Okay, then the plus 20 will just be 20, and then the square root of 0 is 0, so plus or minus 0 is still going to be 20. So we have 20 over 50, and that can be reduced to 2/5. Okay, and again, this is what it means by one repeated solution, right? Up here. All right, so that was the last thing we needed to learn, which was using the quadratic formula. So, all right, so the methods we needed to learn, we have completed them. So again, this section, we make sure we know how to solve by factoring, solve by square root method, solve by completing a square, and then solve by the quadratic formula. Okay, so you'll be tested in all of these areas.